So let's start. Today, again, we will solve more integration rules. Okay, these are still under indefinite integrals. We will use substitution method in solving integral problems or integration problems. So we have here number 1, evaluate each of the following integrals. So let's start with number 1. So we will change the color to black. So that it could be a neutral color. Is it neutral? Anyway, it's two colors, standard, black and white. So let's solve the integral of 4 times the square root of 5 plus 90. That is plus 12 times the quantity of 5 plus 90 quantity raised to power 7 dt. Again, remember, most in these problems, we will use the use substitution method. That means that um, we can represent some of the terms here as u. Say, for example, 5 plus 90 can be replaced or substituted using u. So that is use substitution. Because there are cases, most or many times, that we cannot directly get the integral of a given problem. So we will use a substitution method to represent a certain term. In this case, as you can see, we have here 5 plus 90. Both have plus 5 plus 90. So we can say if we will let u be our 5 or equal to 5 plus 90, and if we get the derivative of u, which is du, the result would be derivative of 5 is 0. Then you have plus 90. The derivative of that is 9 dt. Right. But we only have here dt. So we can say that our du, the cross multiplication method, du over 9 is equal to dt. Then this will become here. So 4. So we will integrate them separately since there is a plus sign here. So this would be a different integration, and this is another different or another integration process. Then 4 times the integral of square root of 5 plus 9 t dt plus 12 times the integral of 5, the quantity of 5 plus 90 to the power of 7 dt. We have here earlier that if we let u be equal to 5 plus 90, so this is then 4 times the integral of the square root of u. Then we have here dt, which is du over 9. And in the next term, this is 12 times. So 5 plus 90 is u, so that will be u raised to power 7. And dt is du over 9. Then we'll move out the constant. So that is rewriting. That is 4 over 9 times square root of u can be expressed as u to the power of 1/2. Then do not forget to multiply it by du. Plus 12 over 9 is 4 over 3. So both are divisible by 3. So if we will divide this by 3, and the lower is divided by 3 because 3 over 3 is just equal to 1. So we change the form but not the value. So this is equal to 4 over 3. So this is 4 over 3 times the integral of u to the 7 over times du. if you look at this, this is now easier to integrate. So we have 4 over 9. So the integral of u to the power of 1 half is u to the power of 1 half plus 1 over 1 half plus 1. So we will place in the denominator the exponent plus 1. Then plus 4 over 3 times u to the power of 7 plus 1 over 7 plus 1. And we should not forget to write c. So a c again could be any constant value. Simplifying, this is 4 over 9 times u to the 1 half plus 1 is u to the 3 halves. Here, u 1 half plus 1 is also 3 halves. Then plus 4 over 3. U to the 7 plus 1 is 8. U to the 8 over 8 plus c. Now remember that, okay, but before that, we have to simplify this first. So this is 4 over 9 times 2 over 3 times u to the power of 3 over 2. Then we have plus, this is 2. So this is 1 over 6 times u to the 8 plus c. This is now 8 over 27 u to the 3 halves, 3 half, 3 over 2, 1 over 6 u to the 8 plus c. But earlier we let u equal to 5 plus 9t. So if you substitute now the value of u, this will become 8 over 27 times 5 plus 9t quantity raised to power 3 over 2 plus 1 over 6 times the quantity of 5 plus 90 quantity raised to power 8 and plus c. This should be our final answer. So let's check it with Paul's answer. We can go to, or we can click solution. Hope this is correct. We have, or we can directly show all steps. So we have here, oh no. Okay. We have here, what's this? Our u, so that, why, what happened? Let's check our solution. So we have du over 9 dt. This is correct. Then we have 12u. Then that's 1 over 9. It's 4 over 9. And okay, we have here u to the, so that's 4 over 9. Then 3 halves. Yeah, we actually have the same answer, but Paul factor out 9, 1 over 9. Let's just check though, just to prove that we have the same answer. So if we factor out 1 over 9, what will happen? So here, 27 divided by 9, the result is 8 over 3. We have 5 plus 9t, that's to the power of 3 over 2, which is the same here. Okay, then how about 1 over 6? What will happen if we divide, we move out 1 over 6 from this, so that the result is 1 over 9. So what shall we divide to 1 over 6? That will be x, so that the result is 1 over 9. So we can cross multiply. So that's x is equal to 6 over 9, or x is equal to, both are divisible by 3, so what will be left is 2 over 3, which means we have 2 over 3 here times the quantity of 5 plus 90, quantity raised to power 8, then it'll have plus c. So if you check, we have the same. They have the same values actually, but Paul has or had multiplied or factored out 1 over 9. But if you distribute 1 over 9, the result would be this. Therefore, our solution is correct. Luckily, our solution is correct. All right, I'm back. Sorry about that. And I don't know if I was audible because I forgot to unmute the microphone. But let's continue. So I have already solved problem number 2. We'll proceed to solving problem number 3. So we have here, find the integral of 6e to the 7w. Then we have 1 minus 8 times e to the 7w quantity raised to power 3. Then we have plus that's 14 e to the 7w over 1 minus 8 e to the 7w dw. I think we have a hint here that the one that we will be um, letting as u is this. Okay, that's 1 minus 8e to the 7w. So if we would let let's let u be equal to 1 minus 8, that's e to the 7w, then we'll get du. If we get the derivative, so it will be negative 8 times 7, then that will be e to the 7w, which means 8 times 7 is 56. So that's du is equal to negative 56 e to the 7w. Oh, I forgot to write derivative of w. Okay, we have here e to the 7w, e to the 7w, dw. So that should be du over negative 56 is equal to e to the 7w dw, which means this will become 6 times. So e to the 7w dw is du over negative 56. And they will all be divided by u cubed. Then my plus, rather, that's 14 times the integral of du over negative 56 over u. So if we rewrite this, this will become 6 over negative 56 commonly. So let's follow the solution of, okay, let's just use this. This will become negative 6 over 56. Then times integral of du over u cubed. Then this is negative, so this will become negative 14 over 56 times integral of du over u. We can simplify this. We have 6 over 56. Both are divisible by 2. So this is 3. 56 divided by 2 is 28. So is 28 divisible by 3? I think not. Then we also have 14 over 56. Both are divisible by 7. Okay. Or I think 56 is divisible by 14. Let's check. Before, if this is 4, so that will be 4 times 4 is 16, carry 1. 4 times 1 is 1 plus 1, so that's 6. So this is actually 1 over 4. Which means this is been simplified. This is 3 over 28 times integral of du over u cubed minus 1 over 4 times the integral of du over u. So the integral of du over u cubed, this can be rewritten as integral of u to the negative 3 du minus 1 over 4 times the integral of du over u. So this is du over u. Evaluating the integrals, the result will be u to the negative 3 plus 1 over negative 3 plus 1 minus 1 over 4 d over u. The result is ln. I think that's natural logarithm. We have 1 over x, just like this. Now that's du over u. So the result is ln of u. And we shouldn't forget to add plus c. Simplifying. So we have here negative 3 over 28. And that's u to the negative 2 over negative 2 minus 1/4 ln of u plus c. We can multiply this to here. The result will be positive. So this is now 3 over 56 times u to the negative 2 minus 1/4 ln of u plus c. Take note that we let u be equal to 1 minus 8e 7 to the power of 7 w. Substituting the value of u, you'll get 3 over 56 times 1 minus 8 e to the 7 w raised to power of negative 2 minus 1/4 ln of 1 minus 8 e to 7 w plus c. And this is our final answer. So let's check. Okay, let's check. Where is it? Show steps. Okay, let's go to the final answer. So we have here 1 minus 8e 7w raised to negative 2. We have ln of 1 minus 8e to the 7w. So usually, or I think Paul likes to factor out the commonly these. No, in letting use substitution, so it factors out this part here, negative 1 over 56. But if we evaluate this, now let's check. If we multiply negative 3 and negative 1 over 56 and negative 3, the result is positive 3 over 56. If we multiply this negative 1 over 56 to positive 14 over 56, the result is 1 over 4. If you check this earlier, 14 over 56 is just 1/4, which means we have the same answer with Paul. And our solution is correct. Now let's try. Which shall we try? How about number 5? Okay, let's check if we can solve number 5. I think 5 can be solved. Yeah, they won't place a problem here if it can't be solved. But let's check. E to the z plus, so I'll just place here a horizontal line so that I can identify that it's letter z, plus 4 sine of 8z over 1 plus 9 cosine of 8z, then dz. So we can integrate them separately. We can integrate these whole problem, or we can separate them and integrate them. This is e to the z dz plus, so we can move out 4 since that is constant, sine of 8z all over 1 plus 9 cosine of 8z dz. For this case, we can easily get the integral of e to the z dz. For the second term, we have to let u be equal to, we have to let u be equal to 8z, so that the derivative of u is 8 dz, which means our dz, or the derivative of z, is du over 8. Okay, we can integrate it directly. The result would be e to the z plus 4 times the integral of sine of u. What's this? Sine of u over 1 plus 9 cosine of u. Then we'll have du over 8. Okay, but there is another problem here. We have e to the z plus 4. And we have here 1 over 8 times 1 over 8 times integral of sine of u, the 1 plus 9 cosine of u du. Can you see this? We don't have an integral for this term. What shall we do with this? So let's try to use another variable. If I would let v, let's try v. If v is equal to 1 plus 9 cosine of u, then the derivative of v will be 9. What's the derivative of cosine? So if it's cosine, so the derivative of cosine is negative sine. So that will be negative sine of u du. Or dv is equal to negative 9 sine of u du. Then cross multiplication, dv over negative 9 is equal to sine u du, which is now our numerator. All right. Moving on. This is, we'll have plus c here. Okay. Since you already have integrated e to the z, so we'll just put plus c. Okay. This is e to the z plus 4 times 1/8 is 1/2 times the integral of sine u du is dv over negative 9 all over v. This is v. Shouldn't forget plus c. Then this will become e to the z in minus, since you have here negative 9. This is okay. Let's just write it step by step. So become times 1 over negative 9 times the integral of dv over v plus c. And that's e to the z plus Okay, this now becomes negative. So 1 over 18. What is the integral of dv over v? That's ln of v plus c. But our v is equal to 1 plus 9 cosine of u. So this is now e to the z minus 1 over 18 ln of 1 plus 9 cosine of u plus c. However, it is not yet the final answer since we have let earlier u be equal to 8z. So that's 8z. Therefore, our final answer is e to the z minus 1 over 18 ln of 1, or the natural logarithm of 1 plus cosine of 8z and plus c. Let's solve and check if it's the correct answer. So this is number 5. Okay, number 5. Let's view the steps. Right, the final answer is e to the z 1 minus 1 over 18 ln of 1 plus 9 cosine 8z plus, which means we got the correct answer. Okay, so this is a series of substitution. Here we have used two substitutions, u and v substitution method. Let's answer number. We're done with 5. So let's keep some items. I have here trigonometric function. Which will we try? Let's have number 10. Okay. So 10 is somewhat complicated in its form, but let's check if we can answer number 10. So that is the integral of secant. Okay, sorry about that. I think I got flu. Colds. So the integral of secant squared times 2t. Oh no, I will have to write in this form. T times the quantity of 9 plus 7 tangent of 2t minus tangent squared of 2t, then dt. Let's distribute secant squared since we cannot integrate them in just one go. So let's distribute secant squared, so the result will be 9 secant squared 2t plus 7 secant squared 2t times tangent of 2t minus secant squared of 2t, then times tangent squared 2t, and dt. Let's check first if we have um, integration or integral formulas about this. Let's go to Bijos side. So we only have here secant x, tangent x, secant squared x. Um, these are only the two. Secant squared x, secant x tangent x. We have tangent of x. Do we have, yeah, we have tangent squared. We can integrate this one directly. Or, yeah, this is the only one. We have to use other trigonometric identities to solve for these other remaining two. But before that, let's change this first to u because it would be easier to integrate if it's only a variable, single variable without any coefficient. So we'll have to let u be equal to 2t so that the derivative of 2t is 2 dt, or du over 2 is equal to dt. So if you rewrite this is then 9 times the integral of secant squared of u plus 7. Okay, since I've already moved out 9, so this will become du. That's d over 2 plus 7 times secant squared. What happened? What's happening? I can't use my mouse properly. So secant squared of u tangent of u du minus the integral of secant squared of u. So this is du over 2 and tangent squared of u du over 2. Right. Next is okay, let's move out 1/2. So that's 9 over 2 times the integral of secant squared of u du plus 7 over 2 times the integral of secant squared of u tangent of u du minus 1/2 times the integral of secant squared of u tangent squared of u and du. Okay, we have to check for trigonometric identities. It's very hot here in the Philippines. All right. We have some identities that secant is equivalent to 1 over cosine. So secant of u is equal to 1 over cosine, while tangent is this. Tangent is equal to sine over cosine. However, what shall we do here? How about for secant squared? So let's check by just formula for trigonometric identities. So let's search this. Trigonometric identities. Okay. So let's move this one. Oh no, here. Okay. Trigonometric identities. Where are you? Where are you? Right. We have here 1 plus tangent squared is equal to secant squared. And let's find the others. We have, how do we solve this? The integral of tangent is ln. The integral of secant is ln of secant plus tangent x. The integral of secant squared is tangent x. That means the derivative of tangent is secant squared x. The derivative of secant is secant x tangent x. What shall we do with this? I don't know what to do with this. Who can help me? Secant q tangent. Hmm, hmm, hmm. So I don't know what to do. If we express them in terms of sine or cosine, then let's say secant is 1 over cosine, so secant squared is 1 over cosine squared. In tangent, okay, I think I have an idea for the second term. So if we let this tangent equal to u, the variable, then the integral of tangent or the derivative of tangent is secant squared. So we can solve this second term. However, for the third term, secant squared and tangent squared, what shall we do with them? All right. Okay. I think okay. If we let, so I think I can solve this now. So what will happen? If we will let v, since we already used u, if we will let v be equal to tangent of u, so let's let, then the derivative of tangent u is secant squared of u du. Secant squared of u du. And we can find here in both terms that these are secant squared u du. So let me just erase this. So we have here secant squared u du. We also have here secant squared u du. Then this will become 9 over 2 secant squared of u times du plus 7 over 2 times. Our v is tangent u, so that's v. Our dv is secant squared u du, so that would be dv. Then minus 1/2 times the integral of tangent. V is our tangent u, so this is v squared. Then you have secant squared u du is dv. So it's much easier to solve now. So let's get the integration or the integrals. That's 9 over u. The integral of secant squared is tangent. So this is then tangent u plus 7 over 2. The integral of v is v 1 plus 1 over 1 plus 1 minus 1 half. Then this is v 2 plus 1 over 2 plus 1 plus c. Note that v here is equal to tangent of u, right? Then this can be rewritten as 9 over 2 tangent of u plus 7 over 2. So this will become 7 over 4 b squared minus 1 over 6. Okay, let me write them step by step. Okay. Right, this is v squared over 2 minus 1 half. And this is v cubed over 3 plus c. So let's just erase this since we will not use this here. Simplifying further, this is now 9 over 2 plus times tangent of u plus 7 over 4 times 1 half, that's 7 over 8. No. Okay, this is not 4, so I'm thinking already of the answer. So 7 over 2, so the result is 7 over 4 v squared minus 1 half times 1/3, so that's 1 over 6 v cubed plus c. So this time here we can now substitute v equal to tangent of u. Then we have 9 over 2 tangent of u plus 7 over 4, and v is tangent of u, so this is now tangent squared of u minus 1 over 6 tangent cube of u plus c. But we have let u earlier equal to, what's that? I forgot. What's that? That's 2t. That's 2t. So we will substitute the value for u. So this is now 9 over 2 tangent of 2t plus 7 over 4 tangent squared of 2t minus 1 over 6 tangent cube of 2t plus c. All right, it's quite a long solution. So let's check. This is number 10. Okay. This is right. So he's moving out 1 half, factoring out 1 half. So this is 9 over 2. Then tangent 2t, this is correct. 7 over 4. If you multiply 1 half here, the result is 7 over 4. Tangent squared of 2t, then still correct. Minus. If you multiply 1 half and 1/3, the result is 1 over 6. That's tangent cube of 2t, so still correct, and plus c. And we got it correctly. So it's quite tiring to solve this very, very long solution. So we have used a lot of substitutions. First is u, so that it would be much simpler to look. Aside from that, easier to integrate. So we let u be equal to 2t. Then later on, we let another variable v equal to tangent of u. And as you can see, they are much simpler to look at and much easier to integrate. And this is now our answer. 9 over 2 tangent of 2t plus 7 over 4 tangent squared of 2t minus 1 over 6 tangent cube of 2t plus c. And I think I've got to leave now. It's quite exhausting to review these type of problems. But I hope we can continue this one tomorrow. Please be with me tomorrow. So hope to see you tomorrow. Still same time at about 7:30 or 8 p.m. Philippine time. That's +8. Thank you, everyone. Bye.